Area enclosed by a curve and a line or by two curves. In this video, we will continue with this. You will find this on page 334 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. The figure shows part of the curve y equals square root x and the line y plus x equals 2 intersect at the point A. Find the coordinate of A. So basically, it intersects there. Okay. So find the point of intersection A of the two graphs by solving them simultaneously. So you just put this one equal to this. Okay, first make y the subject of the formula of the other one. Okay, there I did that. And then I basically just going to substitute this one into this one. Okay, and then I'm just going to factorize and I'm going to solve it and I'm going to get my two values, 4 and 1. But because this is 2 and this is before, A is before 2, I know the point A will be x is equal to 1 because A is less than 2. If the curve goes, say, around like this and the line, then it will cut again there at 4. Okay, but it's not happening in the sketch. Okay, so the point A will be 1, and if I take this 1 and I substitute it in any of the equations, I think that one is the best. 2 minus 1, and I get 1, and there is my point. Okay, note, we will use another method to find the area. Okay, now the area of the shaded region. Now in this one, because we're going to use another method, because we have the straight line and we have the curve. But it's not like you can say this one minus this one. So in this case, we are going to divide this area into two parts. And I'm just going to make it a bit bigger. So basically, we are taking that's now the point, and we are drawing a line there. Then we're going to find this area, and we're going to, this is underneath a curve, but this is actually underneath a straight line, and it's forming a triangle. So it can just be half base times height. So that formula. Okay, but let's start with this one. So this one, I will use that formula. There I did this. There I integrated. And it's between the point 1 and 0. And I substitute. And then I will just substitute that point and I get 2/3. And then if I do this, half base times height. So this can be the base. This can be the height. So I just substitute it in its a half. And what do I do with the two values? I just add it up. And there is where I get 1 and 1/6. Okay, this one is actually easy because it's more or less exactly like the same as in the example. But just for a little bit more challenging, you can first do one and then check your answer at the back of the book or in the teacher's guide, the workout solution. But the one that I will do on this video is number 2. So stop the video and you can continue the video as soon as you are finished. Okay, the diagram shows part of the curve. This is the curve, so the function is already more complicated. And the normal to the curve at the point this normal meets the x-axis at r there. Now, can you remember? I'm going to try to draw it in for you. This will be the tangent, okay, at that point. And then this will be 90. Okay. So, okay, this is my tangent. Now, this is my normal. The red is my tangent. Okay, so find the equation of the normal at Q. So it's back to differentiation. So if I go, it's number A. Okay, first write down the function. What is the function? It's y equals, and then it's 5x minus 1. And the best is now I must write it as 5x minus 1 to the power of a half. Don't forget I'm at differentiation. So first I'm going to find the gradient of the tangent at that specific point. Okay, at that point. So if I'm doing that, so I'm going to write it out for you. Find the gradient of the tangent to the curve. Okay, so I'm going to differentiate. So it's dy by dx. It's the chain rule. So differentiate outside, rewrite the bracket, subtract 1, so it's minus a half, multiply, differentiate the inside of the bracket. So what will I get? I will get 5 over, and I will get 5x minus 1. That will be my answer. Okay, now at the point, what will be the gradient? I'm going to substitute at the point. Okay, I prefer to even say when, because I'm only going to work with the x value. Just keep my pen correct. When x is 2, okay, then I'm going to say that dy by dx equals 5 to 5 to minus 1, and that is going to be 5 over, okay, this is going to be 10 minus 1, it's 9, so the square root of 9 is 3, so 3 times 2 is 6, it's 5 over 6. But that is the gradient of the tangent. So, let's make it blue. Therefore, gradient of the normal at Q is negative 6 over 5. Okay, so the equation of the normal at Q is, and now I use that formula, y minus y1, and because I'm using, it's actually this one, but just remember that if I'm using this one, it's just m. Because this is already negative 1 over m. Just keep that in mind. Okay, so what is my point Q? Then let me see, where did I write? This is Q, so this is x1, y1. So it's y minus 3 equals, I already swapped that. So this is going to give me y minus 3 negative 6 over 5x plus 12 over 5. So this is going to give me y equals negative 6 over 5x plus, and now I can just use my calculator, or I can do it without. Remember, if it goes over, it's going to be plus 3. And it's 5 and 2/5. Okay, that is now the equation of the normal. Okay. Find the equation of the normal at Q. That's what I did. Okay, let's move up. Number B. Find the area of the shaded. Now, if I move up, yes, I think just to get myself space, I'm going to write it here. So if I have to reflect back to it, I'm having it 5x plus 5 and 2 over 5. Okay, and now I'm just going to okay. So don't forget that now I'm going to work with this. Okay. So find the area of the shaded region. Now, first I'm going to work with this side. Okay. So if I'm going to work with this, what I need. Okay, I think I will later do this. Let's just work with this side first. So the area to find the x-intercept of the curve at the normal at y0, find the x-intercept of the curve. Shaded area is divided into, okay. I just need, I need what I need. I need this point. Do you agree? So if I want to see, right, let's just start. Oh, my pen. Where the curve cuts the x-axis. Y is equal to 0. So in that equation, I'm going to say 0 equals 5x minus 1. If I square this side, doesn't matter. So actually I'm squaring and I'm squaring. So it's just going to give me 0 equals 5x minus 1. So 5x equals 1. Therefore, x is equal to 1 over 5. Okay, so it cuts there, and I want to make it, it's at 1 over 5. Okay, there, okay. So, and there, what is this value of x? 2. So, if I want to find the area, area from 1 over 5 to 2. I'm going to use this green. I'm going to use the curve. Can you see that? So I'm going to say the area, and it's between 2 and 1 over 5. And what is my formula? Can you still remember that? I'm just going to write it down here. The formula of the curve, this is the curve, was 5x minus 1. So basically, it's going to be, okay, I prefer, I'm just going to, sorry, I'm correcting myself. That is going to be 5x minus 1 to a half. Work with that, not in the root. Okay, so it's going to be 5x minus 1, and it's going to be a half, and I integrate to x. Okay, so if I'm going to find this one, if I'm going to integrate, now I integrate. So remember, it's that rule, ax plus b to the power n. So it's going to be 1 over 5 multiply, then it's that 5x minus 1. If I add 1, so plus 2 over 2, it's 3 over 2. And I divide by 3 over 2, and it's 2 and 1 over 5. So this will be 1 over 5 multiply 2 over 3, and that's 2 over 15. Okay. So basically, let's just rewrite this. I prefer first to simplify it. So it's 2 over 15, and if I'm taking this back to the root, I can, or I can just leave it in fractions. I think I'm going to take it. It's not difficult, and because that's on top. So let's write it in the root. So it's 5x minus 1. Now just remember it's to the power 3. My pen again. And there is the 2. Okay. And it's 2 and 1 over 5. Okay. And now I'm going to just start with the substitution. So it's going to be 2 over 5. 5, and if it's x, in the place of x I put 2 minus 1, and that's to the power of 3, minus 2 over 5, and in the place of x I put 1 over 5 minus 1, and that's to the power of 3. Okay, so basically that is going to give me 2 over 5. Can I just work with this? So it's going to be 10 minus 1, it's 9. So it's 9 to the power of 3, and then it's the square root, and that's 27. Okay. And this is going to be 2 over 5. Let's just work this. This is just going to be 1 minus 1. This is going to become, this is going to become 0. That is going to, because it's 1 minus 1, so it's 0 to the power, so it's 0 multiplied. So this whole thing, I think I'm just going to correct it there, because I realized it now, that this is just going to become 0. So it's multiplied, and that is going to give me an answer of, let's just see if I made a mistake here. 3 over 2, it's 2 over 5, 2 ABC 5 multiply 27, and 4 over 5. I just want to see, I see my mistake. It's usually I have a correct answer, and then you see, so then you just have to go up. You see, instead of writing the 15, I was making that mistake. So it's 2 ABC 15 multiply 27. That is now the correct answer. The answer you will find at the back of the book. Okay, not yet. This is not the final answer. You will find it in the teacher's guide. The in-between steps. Okay, now that was now the area of that, but I don't want to clean it now. So, if I know the first thing, can I just show you here? Take a little bit. I must find that point where it cuts with a normal, and let's write it like this. Intersect the x-axis. You still make y0. So take the normal, there is the equation, and in the place, okay, this is the normal. And in the place of this, you put 0. Okay, and if I move it up now, just you can take this one over, so it's going to be 6 over 5x equals 5 and 2 over 5. And if you just divide this by 6, so it's going to be 5 ABC, 2 ABC, 5 divide 6 ABC 5 equals, and that's going to give you 4.5. What does that mean? Always think the whole time you're working, you must just think, what does that mean? What did I do now? I was finding this place here is 4.5. Okay, so if I now this is now just the area from, let's just move it up a little bit. It was from 2 to 4.5. You can, but I think you can do it with trigonometry also. Let's see, with a triangle. You can work with that curve, or you can just do it with trigonometry, which is just going to give you, because this is going to be 2.5. Okay, so can I just go back? But you can do it with integration, but I think it's going to be a longer process. Can I just show you here? This, what is my color? Yellow. This is going to be 2.5. That's the base. And what is this? Because it's a triangle. This, it's up to 3. So what is that going to be? 3. Okay, so it's just 2.5 and 3. So basically, I can just go, and can you see, it's just a triangle. Okay, so its area equals half base times height. And remember, that was 2.5, and that was 3, and that, and I'm just, so it's just going to be a half, 2.5 times 3. And if I do that, 2.5 times 3 times 0.5 equals 3.75. And that's going to be 3.75 units squared. Okay, so here comes the final. So therefore, the total what is that total shaded area? That is going to be 4.5 plus 3.75. And that is going to give me, okay, let's just see, 3, no. Oh, this sum becomes too long. That's incorrect. I was taking just that point, and there's the units. So it was 3 and 3 over 5. That's better. So 3 and that will give me an answer of 7 and 7 over 20. Or, what was my other one? What did I found that one? Oh, it doesn't matter. Okay, because it was that 7, I was having a decimal. Or 7.35, and that's units squared. Okay, it's really not so difficult. So if you see straight lines, just go to a normal triangle. But if you were doing this, I just want to show you, I'm not going to do it. Say, for example, you were doing this after you got that 4.5, and you were taking that, you could have, and you could have said 4.5. Oh, let's just make it 4.5, and you could have 2, and you could have taken the normal formula. And you would have also got that 3 and 0.75 units square. But I think this one was easier.